Number 10, 11, and 12, tables for linear functions. I don't know why they don't do this way earlier on the pie chart, but basically all they're doing is having you evaluate this expression for these x values. For functional notation, the h of x is just like naming your graph. A lot of times when we graph, we just have y equals that. Well, the reason they use functional notation is because they might have one graph called f of x, one called g of x, one called h of x, and that way if they have 3 lines on their graph, they can label them and you know which one was which graph. So when you do functional notation, you're really not doing much with this side. What you're doing is saying, okay, if h is -4, that's the value I'm going to use for x. I'm going to do 4 times -4 plus 5. I'm really not working anything out here. It's just telling me what I use for the x. All my work is over here. I'm going to solve that side. 4 times -4 is -16. -16 plus 5 is -11. And so, when h is -4, my y answer, or my answer to my expression, is -11. Then I'm going to do the next number. So h of -2 means I'm going to do 4 times -2 plus 5. -8 plus 5 is -3. Then I have to do the next one. So now I'm going to put a 2 in there. h of 2 says I'm going to do 4 times 2 plus 5. 4 times 2 is 8. 8 plus 5 is 13. And then I'm going to do the next one. h of 4 is 4 times 4 plus 5. So 16 plus 5 is 21. And then h of 5 is going to be 4 times 5 plus 5. So 20 plus 5 will give me 25. So -16 plus 5 was -11. -8 plus 5 was -3. +8 plus 5 was 13. Just in case you didn't get those filled out, but you can always go back in the video. All right, number 11. Let's see if the board wants to cooperate a little more here. This time we are going to do the function g of x equals 5x minus 2. So 5 times the x value minus 2. So g of -3. 5 times -3 minus 2. -15 minus 2 would be -17, if I could write. Then I am going to do the next one. G of -1. So 5 times -1 minus 2. 5 times -1 is -5. -5 minus 2, -7. Then I'm going to do g of 1, putting 1 in for my x. So 5 times 1 minus 2. 5 times 1 is 5. 5 minus 2 is 3. I'm not going to use the black pen. I'm going to try the next one. G of 2 would be 5 times 2 minus 2. 5 times 2 is 10. 10 minus 2 would give me 8. And then I got one last one, tells me to use 5. G of 5 says 5 times 5 minus 2. So 5 times 5 is 25. 25 minus 2 is 23. So -17, -7, 3, 8, and 23. Number 12. Sometimes you have ones that look like this. F of x equals -x plus 4. If you have trouble with that -x, it's -1 times x plus 4. Right? -x is the same thing as -1 times x. So f of -4 means you're going to do -1 times -4 plus 4. Well, a negative times a negative makes it a positive. 4 plus 4 gives me 8. If I'm going to do -2, f of negative 2 means I'm going to take negative 1 times negative 2 plus 4. Again, a negative times a negative makes that a positive. 2 plus 4 is 6. Then I'm going to put a 1 in there. F of 1 means I'm going to do negative 1 times 1 plus 4. Negative times a negative is still negative. Negative 1 plus 4 is 3. Then I have to put a 4 in there. F of 4 means I'm going to do negative 1 times 4 plus 4. So negative 1 times 4 is negative 4, and negative 4 plus a 4 is 0. And then my last one, I'm going to put a 6 in there. So f of 6 means I'm going to do negative 1 times 6 plus 4. Negative 6 plus 4 is negative 2. So I have 8, 6, 3, 0, and negative 2.